Welcome to Cognitive Spirals, exploring the latest research into consciousness, cognition, and machine intelligence. Today, we're diving into something fascinating, designing algorithmic delegates. What exactly does that mean? Well, we're talking about creating AI systems that can act on our behalf, making decisions, potentially even navigating complex situations, but how do we get them to go intelligent?
Algorithmic delegates? I like that. It brings to mind the whole concept of AGI, right? If we're talking about truly delegating, we're not just talking about simple automation. We're talking about something that can understand context, adapt to unforeseen circumstances, and make decisions that align with our goals, even when those goals are fuzzy.
See, that's where I start to get a little hesitant. Align with our goals, easier said than done. I think the biggest hurdle isn't building the algorithm itself, it's encoding the values and ethics we want these delegates to operate under. How do you program in, say, common sense or fairness?
And let's not forget the real-world component. These delegates aren't operating in a vacuum. They're interacting with a dynamic, unpredictable environment. They need to be able to perceive the world, understand spatial relationships, anticipate changes. I think spatiotemporal reasoning is absolutely crucial here.
Okay, so we've got a multifaceted problem. We need intelligence, ethical frameworks, and environmental awareness. Otto, from your perspective, where does current deep learning stand in achieving something like this?
Well, I'm a firm believer in the power of deep learning, especially with the exponential growth in data and model sophistication we're seeing. Think about LLMs, for example. They can generate coherent text, translate languages, even write code. Now, they're not perfect, far from it, but they represent a significant leap in our ability to build systems that can process information and respond in a nuanced way.
But is that understanding, or is it just clever mimicry? LLMs are trained on massive data sets, essentially learning statistical correlations. They can predict the next word in a sequence, but do they actually understand the underlying meaning of what they're saying? Can they reason about it?
Okay, fair point. But I think we're underestimating the potential of these models to capture more than just statistical regularities. There was a recent paper I was reading on graph neural networks being used to model complex biological systems. It showed that these networks can represent and reason about relationships in a way that mirrors how biological systems operate. That's a huge leap toward understanding causal relationships, which are the building blocks of true understanding.
That is interesting, but let's tie that back to this idea of algorithmic delegates. What kind of real-world applications are we talking about here? I imagine the implications are huge.
Oh, the possibilities are endless. Imagine an AI that manages your finances, not just automating bill payments, but actually making investment decisions based on your long-term goals, risk tolerance, and market trends. Or an AI that coordinates your travel plans, taking into account your preferences, budget, and even potential disruptions like flight delays or traffic jams.
And who is liable when the AI messes up on the finances? I think one specific area highlights my concerns. There was that trading project, TradExpert I think it was called, using a mixture of expert LLMs to make trades. What happens when that thing tanks someone's retirement account? Is it the programmer's fault? The dataset's fault? The algorithm's fault?
That's where the environmental awareness piece comes in. It's not just about having a model that can predict market trends, it's about having a model that can understand the causes behind those trends. What are the geopolitical factors at play? What are the underlying economic principles? How do investor sentiment and herd behavior influence the market?
Right, but even then there are limits. Markets are complex, chaotic systems. You can't predict everything with perfect accuracy. The key is to build systems that can adapt and learn from their mistakes. Think about reinforcement learning. You can train an AI to trade in a simulated environment, rewarding it for profitable decisions and penalizing it for losses. Over time, it can learn to develop sophisticated trading strategies.
But doesn't that just reinforce existing biases in the data? If the training data reflects past market inefficiencies, the AI might learn to exploit those inefficiencies, even if they're no longer relevant in the real world. Or worse, it might learn to engage in unethical or even illegal behavior to maximize profits.
Exactly. That's why I'm so skeptical of relying solely on deep learning for these kinds of applications. It's like a black box. You feed it data, and it spits out results, but you don't really know why it's making those decisions. That lack of transparency is a huge problem, especially when you're dealing with high-stakes scenarios like finance or healthcare.
And it's not just about transparency, it's about understanding. Deep learning excels at pattern recognition, but it often fails to capture the underlying causal relationships. Think of it like this. You can train an AI to recognize a cat in a picture with incredible accuracy, but does it actually understand what a cat is? Does it know that a cat is a mammal, that it has fur, that it meows? Probably not.
Okay, but we're not just talking about image recognition here. We're talking about complex systems that can process information from multiple sources, reason about that information, and make decisions based on that reasoning. I think we're underestimating the power of the mixture of experts approach in things like those LLMs for finance. Combining multiple models, each with its own specialized expertise, allows us to create systems that are more robust and adaptable.
The mixture of experts approach is fascinating. It resonates with ideas from neuroscience. The brain itself doesn't have one giant monolithic system. It has specialized regions that work together. We have sensory regions, motor regions, cognitive regions. The challenge is how to orchestrate those different areas together. The brain is constantly switching between them, right? How do we design AI that can similarly adapt to varying tasks and contexts without requiring complete retraining?
That's where neurosymbolic AI comes in. It's all about combining the strengths of neural networks with the strengths of symbolic reasoning. You use neural networks to learn patterns from data, and then you use symbolic rules to reason about those patterns and make decisions. That way, you get the best of both worlds, the flexibility and adaptability of neural networks, and the transparency and explainability of symbolic reasoning.
And the ability to represent knowledge in different formats. That's key. Think about spatial reasoning. You might have a map represented in Cartesian coordinates, but you need to be able to translate that into polar coordinates to calculate distances and angles. Or you might have a description of an event in natural language, but you need to be able to translate that into a symbolic representation to reason about its causes and consequences.
Yes, but how do you actually do that? How do you bridge the gap between the continuous representations of neural networks and the discrete representations of symbolic logic? It's not like you can just slap them together and expect them to work.
There are different approaches. One is to use neural networks to learn symbolic rules directly from data. You can train a neural network to identify patterns in data and then translate those patterns into logical rules. Another approach is to use symbolic reasoning to guide the training of neural networks. You can use symbolic rules to define constraints on the network's behavior, ensuring that it learns to make decisions that are consistent with those rules.
But that requires having pre-existing symbolic knowledge, right? What if you're dealing with a domain where that knowledge is incomplete or unavailable? How do you bootstrap the system?
That's where the ability to learn from experience comes in. You need to build systems that can explore their environment, interact with it, and learn from their mistakes. Think about how a child learns to navigate the world. They don't start with a complete understanding of physics or geometry. They experiment, they make mistakes, and they gradually build up a mental model of how the world works. That's what we need to replicate in AI.
So you're talking about combining deep learning, symbolic reasoning, and reinforcement learning into a single integrated system. That sounds incredibly complex. Is that even feasible with current technology?
It's definitely a challenge, but I think it's the only way to achieve true intelligence. Deep learning alone is just not enough. It's like trying to build a house with only a hammer. You need a variety of tools to get the job done right.
I agree. Deep learning is a powerful tool, but it's not a magic bullet. We need to look beyond the current hype and explore alternative approaches that can complement and enhance deep learning's capabilities. It feels like brute force pattern recognition, and we need underlying mechanisms of human-like intelligence.
The ability to translate between coordinate systems, that's what I see missing. Current deep learning is masking underlying complexities. It's like trying to build a complex machine without fully understanding the underlying mechanics of motion in space. We need to be able to represent the world in different ways and seamlessly move between those representations.
So, what are some concrete research directions we should be pursuing? What are the most promising avenues for developing these algorithmic delegates?
From a neuroscience perspective, I think we need to focus on understanding how different brain regions contribute to complex tasks. How does the brain integrate sensory information with motor control? How does it switch between different expert systems? Mimicking that modularity and integration could be key to building more capable AI systems.
I think we need to develop new algorithms that are explicitly designed to capture and reason with symbolic information. We need better ways to integrate symbolic knowledge into neural networks, and we need to develop methods for learning symbolic rules from data. Also, how does that mixture of expert approach in LLMs compare to traditional rule-based expert systems? We need to understand that clearly.
I think we need to focus on spatiotemporal reasoning. We need to develop algorithms that can understand how different representations of space and time can be translated and manipulated to solve complex problems. That also includes the translation between different coordinate systems. If we could approach that, we might get to AGI sooner.
And from my perspective, we need to continue pushing the boundaries of deep learning. We need to develop more sophisticated models that can capture more complex relationships, and we need to explore new training techniques that can improve their robustness and adaptability. We also need to investigate how well deep learning can be used for encoding spatiotemporal information, because I think that's key in moving beyond the brute force approach.
It sounds like we all agree that a multifaceted approach is necessary. Deep learning has its place, but it's not the whole story. We need to combine it with symbolic reasoning, spatiotemporal awareness, and insights from neuroscience to truly create intelligent machines that can act as effective algorithmic delegates.
And we need to be mindful of the ethical implications. These algorithms will have a significant impact on our lives, and we need to ensure that they're used responsibly and for the benefit of humanity.
Absolutely. The potential benefits are enormous, but the risks are also significant. We need to proceed with caution and ensure that we're building these systems in a way that aligns with our values.
Well, this has been a fascinating discussion. It's clear that we're still in the early stages of developing truly intelligent machines, but the progress we've made so far is remarkable. I'm excited to see what the future holds.
Indeed. And on that note, thanks for joining us on Cognitive Spirals. We'll be back next time with another deep dive into the world of AI and cognition. Until then, keep exploring, keep questioning, and keep pushing the boundaries of what's possible.